Oh yeah, welcome back to Galantitos Academy. I'm very sure you guys have missed us now, but no problem. We'll be dropping video more frequently now. So ensure you invite your friends, ensure you subscribe, turn on the notification bell. Right. So today we'll be treating a very simple concept called vector addition. Right. Vector addition. This is a topic that every student of physics should know, right? So let's dive in. So for today, I'll be giving an overview of what we'll be doing, right? I'll just give you an overview of what we'll be doing. We won't really solve questions, right? There will be a separate video for that where we'll solve questions and questions and questions and questions, right? All right. So first, before we move into what vector quantities are, what exactly do you know? What do you understand by vectors? Right. I'm very sure you all know what scalar quantity is too. So vector quantities are those quantities which has both magnitude and direction. So when they say has magnitude, what do you mean by magnitude? It means having um, a quantifiable variable. Let's say like weight, right? Weight, or whatever distance. That's it. Distance can be distance. Let's say 5 meter, right? 6 kg, right, and so on and so forth. All right. So direction means, is it moving towards the um, east? Is it moving towards the south or the west or the north? So that's what the direction is trying to specify, right? So they are often depicted as arrows, right? They are often depicted as arrows. So whenever I see a vector quantity, right, most times they will usually depict it this way, right? Sometimes it can be this way, right? Sometimes it can be this way. Wow. So the length, right, from here to here talks about the magnitude. It talks about the magnitude. Why the direction which this arrowhead is pointing talks about the direction. Right, look at this. If we just draw something like this now, this is more or less like um, this 40 degree. So whenever you are thinking about the direction, you are going to resolve it. Exactly, you're going to resolve it. So this one is towards what? Towards the south. So from here to here, it talks about the distance. Exactly. All right. So that was what vector is all about. So you understand what vector is now. Okay, let's move on. All right. So vectors and scalars are different. Take note of that. Right? Vectors and scalars are totally different. Now, whenever we're adding scalar quantities, we do not take into consideration the direction, right? So, for instance, now if I ask you, um, what's the total length of your clothes, or what's the total length of the, or what's the width of your room? Let me put it that way. Let me put it easy, simple. What's the width of your room? You most likely use a tape and measure it and tell me uh, 25 meter, right, or whatever it is. This is an arbitrary value, right? So you didn't tell me 25 meter in south direction. You didn't tell me something like that. You just told me 25 meter, right? So if I tell you, okay, add the width and the breadth, right? You say 25 meter plus 25 meter, right? What I'm asking you to do is to add the distance. Remember, distance is a scalar quantity. But now, if I ask you the displacement, which is a vector quantity, you're going to do it separately. You're going to do it differently, Do you get that? So adding scalars are very, 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 very simple and straightforward, right? So I can just say, okay, 40 kg plus 50 kg is equal to what? 90 kg, no stress, right? 6 meter minus 3 meter will give you what? 3 meter. No stress. No stress. But when we're adding vector, we take into consideration both its magnitude and its direction. I hope that's clear. Alright, if you don't understand it, just comment in the comment section below so we can come over it again. Alright, so how to add vectors? The method employed for calculation depends on the orientation or the vector involved. That is, where is it pointing to? I guess in that to actually take into consideration. This case one, where they said two parallel forces acting in the same direction. Alright, so let me not make it so vague for you. Let's assume that there is a car right, this is a car, and they said, and it's stranded. Let's say it's stranded here, stranded. It's stranded here. So two parallel forces acting in the same direction. So let's assume we are both trying to push it off here. So I'm pushing at this direction. My friend is also pushing in this direction too. Right? Where do you think this car will move towards? Will it go in this direction or will it go in this direction? Okay, I'm very sure you know about that. But the problem, let's move on. Let's assume I'm pushing it with a force of 20 Newton, while my friend is pushing it with a force of 5 Newton. Let's assume that. Right. So in such a case like this, all you have to do is to add it. So nothing more, add it. And now there is a name we call the addition or the combination of forces, right? It's called what? Resultant. So this is the total amount of force in a particular direction, right? Equilibrant is similar to resultant, right? But we won't be talking about equilibrant in this video. So equilibrant. We'll be talking about equilibrant in this video, right? We'll discuss it when we're treating questions. Good. But for just know that resultant is the total amount of force in a particular direction. Just know that, right? Okay, so for this, since they are moving in the same direction, we are just simply going to add. Nothing more, just add. So just come here and say 20 plus 5 Newton will be equal to what? 25 Newton. So the resultant force right here is equal to what? 25 Newton. So whenever you see two parallel forces moving in the same direction, all you have to do is to what? Is to add. Do not forget. Two forces acting in opposite direction. So what happens when two forces are acting in opposite direction? Let's assume I'm dragging a gift. My mom bought me a gift, right? And I'm dragging it with my brother. Don't mind me. I love gifts. I'm dragging it with my brother. So this is a gift. No one knows what is inside actually, so it's hidden, right? Alright, so here I am dragging with an intensive force of 40 Newton. Can you imagine? While my younger brother, is dragging it with 10 Newton. Ooh, I've won already, I'm very sure. Alright, so whenever you see forces moving in opposite direction, what do? All you have to do is to subtract. I get in? So to find the resultant force here, that is a single force that will replace these two forces, right, is the resultant. I've said that over and over and over again, right? So this single force, right, which is called the resultant. So to find the resultant of these forces, all I have to do is to subtract. So 15 Newton minus 10 Newton. It's as simple as that. Don't forget, when you're moving in the same direction, you do what? You add. When you're moving in the same direction, you do what? You add. So the resultant force is 40 Newton. Looks simple, isn't it? Look very simple. This is the simplest subject. Alright, so this is the case 3. What it said, two forces acting perpendicular to each other. So first, when they say perpendicular, what comes to your mind? Alright, when they say perpendicular, they mean at 90 degrees. So either they say perpendicular or right angle, right? It both means 90 degrees. 90 degrees looks somewhat like this, right? It looks like this, right? Alright, so let's try something. Okay, so how can we find the resultant when there are two forces at right angle to each other? How can we find the force? Let's assume this is F1 and this is F2. When I'm going to solve questions here, there will be a separate video for that. I'm just trying to establish the basics. I'm just trying to establish the foundation, right? Good. Alright, so the resultant force will be in this direction, right, between both forces. That's how the resultant force will be. I get it? Alright, I'll tell you something here, that since this is a square, alright, this is not the drawing is not really accurate, so pardon me. Since this is a square, opposite sides are equal, right? Opposite sides are equal. So it is F1, this is also F1, this is F2, this is also F2. Is that clear? This is also F2. Alright, so I can just literally cut this off to make it look like this. Right, so here becomes F1, here becomes F2, and here becomes our R, which represents our resultant. Okay, whenever you see such a question as this, what you're going to make use of is the Pythagoras theorem. Pythagoras theorem. I hope you haven't forgotten Pythagoras theorem. Okay, which is hypotenuse square equals to opposite square plus adjacent square. That's the formula for Pythagoras theorem. So we're going to relate it to this to get it. So our hypotenuse here is what? R squared. Opposite, you can choose anyone, right? So F1, right? F1 square plus adjacent square, which is what? F2 square. So whether I flip it the other side or not, it's still the same thing, right? So to find the resultant force, when two forces are perpendicular to each other, we're going to make use of the Pythagoras theorem. That is from your mathematics. Alright, so we can say R equals to F1 square plus F2 square, right? So square it. So this is how to find the resultant force. Exactly, that's what we're going to make use of. But most times, when you are asked to find the resultant force of two perpendicular forces, right, they don't stop there. They go as far as asking you to find the direction, right? So the direction. Why they mostly tell to find the direction is to actually get this angle here, right? To get the angle. Okay, how is this angle acting? Right, that's what they're actually trying to tell you to find. Okay, and most times the direction right? The direction is more or less stable, right? So which is, we're going to want to look for this particular angle, right? So how can we get it? This remember, so car, I wanted to go straight, but I wanted to tell you the how I went about it. So we have this as opposite, we have this as adjacent. Okay, this is the angle we are looking for, right? So that means we're going to make use of TOA, which is tan theta equals to opposite over adjacent. This theta here signifies direction. Is that clear? Okay, so we have tan theta equal to opposite. What's our opposite? F1. What's our adjacent? F2. Is that clear? Good. So making tan theta, making theta such a formula, we have theta equals to tan inverse F1 over F2. So our direction is equals to what? Tan inverse F1 over F2. I hope you know how they came about this. No, now let me just tell you something for your understanding. Okay, so so when we have tan theta equal to F1 over F2, to make theta such a formula, what I'm going to do, I'm going to divide both sides by tan theta. So here will also be divided by, or yeah, tan theta. Let me put it this way, which will also be equal to F1 over F2 times 1 over tan theta. Is that clear? Okay, so when we bring it up, this cancels this up, you know. So theta will now be equal to, in mathematics, this stuff we can also represent it as tan minus 1. I hope that's clear. Okay, so theta will definitely be equal to tan minus 1 F1 over F2. It's as simple as that. Good? Alright, let's go to the next one. Angles between the two acting forces is acute. So when the angle between the two acting forces is acute, how do we find the resultant? Before you move towards that, before you get that, we first have to understand what acute means. Alright, not acute disease, biology student. Alright, so acute actually means angle between 0 degree and 90 degree. That's simply what it means. It's as simple as that. Okay, so what do you think it to be? You know, 90 degree means something like this, right? So you don't expect an acute angle to get to this size. So most of the times it looks like this, right? So less than 90, greater than 0. Alright, so less than 90, greater than 0. Okay, let's try to do something now. Let's try to do something. Okay, so let's assume this F1, this F2. Okay, how did I tell you the resultant will be? It will always be in the middle. So let's complete this. We're going to use parallelogram law, right? I don't want to deviate toward math a lot, so I'll be keeping things really simple, right? So in parallelogram, there are actually some laws or some principles which you have to understand, right? Just, you don't have to cram it. It's just something you can relate using the diagram, right? That's why this guaranteed us. Okay, so under parallelogram, opposite sides are equal. Opposite sides are equal. Opposite sides are parallel too. Opposite sides are parallel, right? Opposite angles are equal. Opposite angles are equal, right? Okay, good. So if this F1, this F2, since I said the opposite sides are parallel, opposite sides are equal, right? F2 is also F2. Exactly. So I can literally bring this section out so it looks like this, just like what I did for perpendicular forces. Exactly. All right. So this F2, this F1. Sorry, this F1, not F2. Look at this. Good. So this F2. Exactly. All right. So in such case as this, we're simply going to use the cosine rule. We're going to make use of the cosine rule to solve this. Exactly. I hope you remember it. So the resultant, to get the resultant here, we're going to say f1 square plus f2 square minus 2f1 f2 cos theta. Right? That's the formula we're going to use to get the resultants in an acute. Right? So how do I come about this formula? There is a way I can prove it, but you don't need it. Right? Now, back to secondary school, back to mathematics, where they say a square can be b square, it can be smaller than b, right, plus c square minus 2bc cos, so this small a, sorry, cos a. I get it. So I just related it to this formula and nothing more, right? So now let me explain to you what I mean opposite angles are equal, because when we start solving questions, you start seeing the interplay of it, right? So now if this is let's say 55 degree, right? If this is 55 degree, what do you expect this place to be? 55 degree too, right? It has to be 55 degree too. All right, because opposite angles are equal. Look at it here. Look at the last statement. Opposite angles are equal, right? Okay, now how do we get this? How do we get this? How can you suggest? Can you type it in the comment section, right? So that you are also learning too. All right, you have to know that the total angle of a triangle is what? 180 degree, but the total angle of a parallelogram is what? 360 degree. So I can represent here as x and here as x too. Why can't I use y here? Because opposite angles are equal. So solving for it, x plus 55 plus 55 is equal to what? 360. So whatever we solve, we have to get 360 as answer. X plus x is what? 2x. 55 plus 55 will give you 110 equals to 360. So 2x is equal to 360 minus 110. So 2x is equal to 360 minus 110 will give you what? Mathematics students. Alright, 250 divided by 2. Divided by 2. Right? So this. So 2 divided by 250 will give you what? 125. So x is equal to 125 degree. So here will also be 125 degree, and here also was 125 degree. Is that clear? Is that really clear? All right. So the key takeaway is this. Right? You shouldn't forget that. You shouldn't forget that at all. Right? So this is what we'll be using in our subsequent solving, like examples. Okay, this is the last part, which is angle between two forces is obtuse. So when the angle between two forces is obtuse, what are we going to do? Okay. First of all, what does obtuse mean? Obtuse simply mean between 90 degree and what? Can you try? Between 90 degree and what? 180. Correct. Between 90 degree and 180. So we expect an obtuse this 90 degree. Right, so we expect an obtuse angle to be somewhere like this. Something like this. Right? So always, just like I've always said, the resultant force will be in the middle of both. So let's join it. So if this F1, what would be this? F2. And note, the parallelogram law, or the principles I stated for parallelogram law in the previous slide, which is the acute, applies here too. Right? So this F1, this F1 too, this F2, and this is also what? F2. So I can literally bring this out. So it becomes somewhere like this. So it becomes F1. So not F1, this will be R, right? Because we're representing this part. We're representing this part of the parallelogram, exactly. So what I'm presenting here. So this F2, this F1, exactly. Alright. So the same formula we're going to make use of is what we're going to be using here too. Right? The same formula and nothing more. Right? Which is what we're going to be using the same formula, which is R square equal to F1, right? Equal to F1 square plus F2 square minus 2F1 F2 cos theta, right? So I'm not solving anything here, right? In subsequent video you will get to know how to use this, right? I'm just trying to establish the basics. I'm just trying to establish the concept, exactly. Alright, so that's basically all you have to know about vector addition. There is one more, right? Before I start solving for the next video, right, I will try to touch that. Alright, so but now for today, this is where we're going to stop. Thank you so much for being with us, and God bless you. Have a great day, and share, subscribe. Don't go yet. Just wait. Subscribe. I subscribe. Good. I like the video, and then share. Thank you. Have a good day. Bye.